with the new chapter. We had started with the chapter solutions. Okay. So in the solution chapter, last class, we had dealt with these MCQs questions. So first 10 MCQs questions were solved. So we'll see the remaining ones. Okay. Yes. So we'll start with the MCQ questions. So the first question, blood cells retain their normal shapes in solutions which are A. Isotonic to blood, B. Hypotonic to blood, C. Hypertonic to blood, and D. Different concentration to blood. Yes. Good evening, Sanjeevni. Yes, so most of them are joining now. Yes. So we'll wait for 1 minute. Yes, so blood cells, okay. How they retain their shapes? In what type of solution do they retain their shape? Yes. Leave your answers in the chat box. Okay. Others? What is the answer? Then I'm going to answer it. Yes, I want the answers from you all first. Okay. Sanjini, Bhavna, Supriya have answered it as A. Yes. So I've got most of the answers now. Fine. So we'll see. So what are the options given here? Okay. So blood cells, they retain their normal shape in what type of solution? So now we'll see uh, what it means by isotonic, okay, what it means by hypotonic, and what is meant by hypertonic. Okay. So what are these terms? What do you mean by isotonic? Yes. So isotonic solutions. Okay. So what do you mean by isotonic solutions? So these are the solutions in which water concentration inside the cell, okay, is same as the water concentration outside the cell. So this is the meaning of isotonic solutions. Okay. So what do you mean by isotonic solutions? So the isotonic solutions are those solutions whose concentration inside the cell is similar to the concentration outside the cell. Okay, so that is the meaning of isotonic solution. So, so here, so that is isotonic. So what will happen? Now suppose, okay, so this is your cell. So the number of molecules entering, okay, will be equal to the number of molecules which are outside. Okay, that is here no movement of any molecule takes place. Why? Because the concentration is same. The net there is no net change. That is called as isotonic because the concentration inside the cell and outside the cell is the same. Okay, so it is called as isotonic solution. Okay, so now next is what? Hypotonic solution. What do you mean by hypotonic solutions? Yes, what do you mean by hypotonic solution? Anybody? What do you mean by hypotonic solution? Hypotonic solution. Yes. So a solution having lower concentration, okay, of the solute. So if the concentration of the solute is less, okay, if the concentration of solute is less, then it is called as what? With respect to another solution, it is called as hypertonic solution. So if the concentration of the solution, okay, that is a solute with respect to another solution is less, then it is called as hypotonic solution. Okay, it is called as hypotonic solution. What do you mean by hypertonic solution now? Yes, what do you mean by hypertonic solution? Whose concentration is more. Okay, so here a solution having higher concentration of the solute. So if the concentration of the solute is higher, okay, if the concentration of the solute is higher with respect to another solution, then it is called as hypertonic solution. Okay, now suppose the blood cells, okay, if the water is flowing in case of your hypotonic solution, what will happen? The because the concentration is less, because the concentration of the solute is less, the water will flow inside the cell. Okay, the water will flow inside the cell, and what will happen? The size of the cells will increase because the water is going inside the cell. So because as the concentration of the solute inside the cell is less, okay, so the water from outside will move into the cell, and what will happen? The blood cell size will increase. Okay, so this is with respect to hypotonic. So what they have said here, the question is blood cells, they are remaining in their normal shape. Okay, they are the blood cells, they retain their normal shape in hypotonic to blood. Okay, what is the what they are saying? That the concentration of the solute is less. Okay, if the concentration of the solute is less, means what? The water from outside is moving inside. Okay, so what is happening? The cell size is remaining same? No, right? The cell size is increasing because the concentration of the solute inside the cell is less. So water from outside is moving, it is flowing inside. So the blood cell size will increase. Okay, now, what do you mean by hypertonic? Yes, in hypertonic, what did we see? In hypertonic, we saw that the concentration of the solute is more. If the concentration of the solute is more, then what will happen? Yes, the water will flow out of the cell. Okay, the water will flow out of the cell because the concentration of the solute is more. Then what will happen to the blood cell? The blood cells will shrink. Okay, the blood cells will shrink. Now, so this is also wrong. This is also wrong. So hypotonic is also not our answer. Hypertonic is also not our answer, because what is the question? They said that the blood cells should be, they should retain their normal shape. Okay, they should retain their normal shape. In hypotonic, the cell size is increasing, and in hypertonic, the cell is getting shrink. Okay, so these two options are discarded. So next, different concentration to blood. No. Okay, so if you take different concentration of blood also, the cell size will increase or either decrease depending upon the condition. So this is also wrong. With respect to isotonic, we have seen that we have seen that the concentration of the cell inside is equal to the concentration of the cell outside, right? So with respect to uh, isotonic, so the concentration of the solute is equal to the, that is with respect to the outside. So the correct answer is isotonic to blood. So when the blood cell, when the concentration is isotonic, okay, that is it is isotonic. That is both the solutions, okay, they are having same osmotic pressure at a given temperature. Okay, that is the concentration of the solution of the water, that is the concentration of water concentration inside the cell and outside the cell is same. Okay, then it is called as isotonic. So option number is the right answer. Okay, so we have seen now what is isotonic, what is hypertonic, and what is hypotonic. Okay, remember these things, don't get confused. And what is the condition? So in hypotonic, the concentration of the solute with respect to the solution is less. Okay, with and hypertonic, the concentration of the solute with respect to the solution is higher. Okay, it is on the higher concentration. So what will happen to the cell? The cell will shrink here. Okay, and in isotonic, what is happening? in this solution, the water concentration inside the cell is same as the water concentration outside the cell. Okay, remember these three important conditions. Okay, so the answer is A. I hope you have got it. Yes? Is it clear? Students, is it clear? Shall we move to the next question? Yes. Yes. Okay, good. So, next question. The process of desalination of water, seawater, is an example of, okay, A, osmosis, B, filtration, C, diffusion, D, reverse osmosis. Yes? Okay, I've got the answers. Okay, so there are many answers. All are saying it as D. Suhas, Bhavna, Jyoti, Lakshmi, Sindhu, Sanjeevni, Supriya, Swati, all have answered it as D. Yes? Anybody else? Okay, Harshita also is saying it as D. What about others? Yes. Good. In YouTube also students are replying. Yes, it is D. Okay, good. So the answer is D. Now, why it is D? What is desalination? Yes, what is desalination? So desalination, okay, desalination of seawater. Remember, if they ask you a question, so this is a very important question, okay, for 2 marks. What is reverse osmosis? And give a example. Okay, so a best example for reverse osmosis is, right, desalination of seawater. So if you write this word desalination, not distillation, okay, many of you, they write it as distillation of seawater. Wrong. Okay, so it is desalination of seawater. Now what is this desalination? Okay, the meaning of desalination is getting pure water from seawater. Okay, so getting pure water from seawater. Okay, so that is the meaning of your desalination, the word desalination. Now, what you are doing in this process of desalination? Yes, you know what is reverse osmosis? Yes, what is reverse osmosis? What do you mean by reverse osmosis? Yes. So suppose I take a container. Okay, I take a big container. Okay, I'll take a big container. In this big container, one side, okay, I've added my normal water. I'll take my normal water at one side, and on the other side, I'll add my seawater. Okay. So one side I've added a normal water and one side I've added the seawater. Now these two types of water, they are this container. Okay, so it is separated by a membrane. Okay, so it is separated by a membrane and this is called as semi-permeable membrane. Okay, so so these two types of water, they are separated by a membrane and that membrane is called as what? Semi-permeable membrane. Okay, so what is happening here? So in water, yes, in water, what is more in water? So this is a solution, right? Water solution is present here, and this is a saline solution. Seawater is nothing but saline solution, and normal water is your water solution. Okay, So in water solution, what will be more? So in water solution, solvent is more. Okay. Water solution, solvent is more and solute is less. Right? Am I right? And in the sea water, okay, in the sea water, our solute is more. Okay, solute is more and solvent is less. Okay, solvent is less. Now, what is reverse osmosis? So the movement of solvent from fresh water to seawater takes place. Okay. So as I'm applying here external pressure. Okay. Now what is happening here? The movement of solvent molecule from this water to seawater takes place. Okay. So the movement of molecules start moving. Okay. The solvent molecules from this normal water, it starts to move from the fresh water to seawater. Okay. Now here, the seawater, okay, it has a osmotic pressure of 30 atmospheric pressure. So it has a osmotic pressure of 30 atmospheric pressure. So now when the solvent molecule, it is start to move. Okay, I'll just take another color. So if the solvent molecule is how it is moving from water, normal water to the seawater, because the solvent molecules is moving from this side, okay, from left to right side. Okay. Now when at this moment, okay, at this moment, I apply a external pressure. Okay, I'll apply what? I'll apply a external pressure. I'll apply a external pressure on this seawater. Okay, on the seawater, I'm applying the external pressure. Okay, so the water from the seawater side, it starts getting into the fresh water. So whatever the water molecule is there, okay, water molecules are there in this seawater, it starts to move in the fresh water. Why? Due to increase in the external pressure. So I'm applying the external pressure more than this 30 atmospheric pressure. Okay. So this is called as reverse osmosis. Okay. So this is called as reverse osmosis. So whenever, so here what is happening? So I've taken a big container. Okay. So these two type of water solutions, they are separated by a semi-permeable membrane. So in one side, I have added my normal water. Another side, I have added my seawater. So in normal water, the solvent is more. Okay, and solute is less. In saline water, solute is more and solvent is less. Okay. So the seawater, the pressure is 30 atmospheric pressure. So when I apply a atmospheric pressure, when I apply external atmospheric pressure more than 30 atmospheric pressure, okay, what is happening? The water from the seawater, it starts moving to the normal water. Okay. So this is due to the external pressure which is applied, and this is called as reverse osmosis. So this is the very good process for purifying your water from seawater. Okay, remember this. So okay, so what is reverse osmosis? So we have seen now what is reverse osmosis. So it is the external pressure greater than the osmotic pressure. Okay, if the external pressure is greater than the osmotic pressure is applied on the solution, solvent molecules flow from the solution to the solvent through a semi-permeable membrane. Okay, so this is called as reverse osmosis. The best example for reverse osmosis is what? Desalination of seawater. So no spelling mistake. So just see the spelling of desalination. So desalination of seawater is the best example. Suppose in the exam, if you do not remember what is reverse osmosis, okay. In the worst case, if you do not remember what is reverse osmosis, if you write the example, okay, if you write the example also, that is desalination of seawater, okay, you will get a 1 mark. If the question is what is reverse osmosis, give an example. So if you don't remember the definition, still if you write the example, you can get a 1 mark. Okay. So please remember what is, so this is a must question. Okay, it is a must question. What is reverse osmosis and give an example. Fine. So we'll go for the next question. two solutions have different osmotic pressures. Okay, the solution with higher osmotic pressure is called as. Yes. Yes, what is the answer for 13? Yes, what is the answer for 13? Okay. Yes, I'll read out the question once more. Two solutions have different osmotic pressure. The solution with higher osmotic pressure is called as A, isotonic solution, B, hypotonic solution, C, hypertonic solution, and D, ideal solution. Now we have seen what is isotonic, what is hypotonic, and what is hypertonic. Now, what is ideal solution? Ideal solution are those solutions which obeys Raoult's law. Okay, which obeys Raoult's law. So this we are going to see in the our further questions. Now for this, yes, what is the answer? So we have seen what is isotonic solution. Yes, so the solution with higher osmotic pressure is, yes, it is C. Okay, so okay. So what is hypotonic solution? First, we'll see what is hypotonic solution. So hypotonic solution, it has a lower concentration of solute, okay, as compared to the cell. So the best example which we had given is the salt water. What is hypertonic? So here the concentration is greater, okay, concentration of the solute is greater on the outside of the cell when compared to the inside of the cell. So it is hypertonic solution. Okay. So we have seen what is isotonic solution. Isotonic solution is what? Isotonic solution, the osmotic pressure is same. Okay. Or the two solutions having same osmotic pressure. So this is also discarded. Ideal solutions are those solutions which are which obeys Raoult's law. Okay. So this is also wrong. So this hypotonic is having a less concentration. Okay. So we'll go for the next question. For an ideal solution, the vapor pressure of a solvent in solution is directly proportional to. For an ideal solution, the vapor pressure of solvent in solution is directly proportional to A, mole fraction of solvent, B, mole fraction of solute, C, mole fraction of solvent and solute, and D, volume of the solution. Okay, I've got mixed answers. Some are saying A, B, D, C. Yes, which is the correct answer? For an ideal solution, the vapor pressure of solvent is directly proportional to its, yes, the answer is A, mole fraction of the solvent. Okay. So the answer is mole. So this is theoretical. So this is based on the law. Okay. So the vapor pressure of the solvent in the solution is directly proportional to its. mole fraction of solvent. Okay. So next question, which condition is not satisfied by an ideal solution? Yes, which condition is not satisfied by an ideal solution? What is ideal solution? First, we'll see what is ideal solution. So ideal solutions are those solutions which follows Raoult's law at all temperature and concentration. Okay. Yes. Yes. Good. Good. Okay. So the answer is D. Okay. So what is the ideal solution? So ideal solutions. So they what they do? They obey Raoult's law. Okay. Then the solute interaction, solvent solvent interaction, and solute solvent interactions are the same. Okay. And then this volume mixing. Okay, so when you are mixing the volume mixing, the change in volume mixing is also zero. The enthalpy change is also zero. So this is the condition of ideal solution. Okay, so this is the correct answer. So D. Okay, it is not satisfied. Okay. Okay. So, so these were some of the MCQs questions which we have solved. Okay. So now moving further, we'll go for the fill in the blanks. Okay. So moving further, we'll go for the fill in the blanks. So these are some of the questions. So the first question is dash in nitrogen is an example of gaseous solution. Yes. 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 Good. Good. Jyoti, Lakshmi, Rohit, Jairam, Suhas. Yes, the answer is right. Yes, YouTube students, please answer. What is the answer for dash in nitrogen is an example for gaseous solution? Yes, yes, good. So there are many of you have answered it right. It is camphor. Okay. You know camphor. What is the state of camphor? What is the state of camphor? Yes, it is solid in state, right? Camphor is solid in state. So it forms a solution. Okay, this camphor, you know what is sublimation before going for yes, what is sublimation? So sublimation is a process wherein the solid is directly converted into gas. Okay, remember this. Yes, please remember this. What is sublimation? Okay, sublimation, it is a process wherein the solid is directly converted into gas. Okay, it will not undergo liquid state. It will not show you liquid state. Directly from solid state, it is going into gaseous state. Okay, now camphor. Okay, did you burn anytime camphor in your house? Yes, during puja, right? When you do God's puja and also that time you use camphor, right? So this camphor, when you light it, okay, what will happen? Directly, did you see any time it is turned into liquid? No, right? Directly, it turns into a gas, okay? Sooty flame like, sooty gas like, okay? So black color smoke like it will come, right? So it is, so the answer is camphor. I'll just explain you. Just a second. Okay, camphor. So camphor, it is solid in state. Okay, so it forms a solution in gases. Okay, why? Due to the property of sublimation. So because it has a unique property of sublimation, okay, it forms a solution in gas. So so solid is directly converted into gas without converted into liquid. So camphor, it has the ability to form gaseous solution, okay, with nitrogen gas. So it has that ability to form a gaseous solution with nitrogen gas. So this is the correct answer. It is camphor. Good. Next question. Alloy. Alloy of copper and gold is an example for. Yes. What is alloy of copper and gold example of? Yes. Okay. Solid solutions. Okay. So you know the gold. Okay. Now gold. So if you take pure gold, okay, if you take pure gold, that is 24 karat gold, okay. So this will be not hard. It will be completely soft, okay. So when you add, if you mix gold, okay. So in this gold, if you add some amount of copper, okay, there will be some hardness. So this will be, it turns into 22 karat, okay. So when this gold and copper, it is a alloy, okay. So gold is also solid, this is also solid. So this is example for solid solution, okay. So this is example of solid solution. Fine. So this is the correct answer. Okay, we'll go for the next question. Camphor, this is solid solution. Next one, an example for a liquid solution in which solute is a gas is. Next question. Okay. Sanjeevni, then Sanjeevni, then again, who has answered it right? Carbon dioxide in water. Okay. Dioxide in water. So an example for a liquid solution in which the solute is. It is what? So example for a liquid solution in which solute is a gas is what? It is soda water. The answer is soda water. Okay. So what is done? In soda water, a gas, okay, a gas is dissolved in liquid, right? So gas is passed. Which is this gas? It is carbonated, okay, it is aerated drinks, right? You called it aerated drinks. So what is done in soda water? The gas is passed, okay. So a gas is dissolved in any liquid, okay, in any carbonated drinks. So what will happen? The gas is infused into this liquids, okay. So the solvent which is used is a water, and the solute is what? It is carbon dioxide gas. So carbon dioxide gas is it is combined with your water, okay. So gas in liquid. So it is a so an example for liquid solution in which solute is a gas is soda water, okay. So here the solute is a gas is the soda water. So which is a solute? uh, that is carbon dioxide, okay. Carbon dioxide is your solute and water is your solvent, okay. So this is the correct answer. Next question. The tanks used for scuba divers are used with air diluted with helium to avoid, this we have seen in MCQs, okay. So you can answer it. The tanks used by scuba divers, yes, it is bends. The answer is bends, to avoid bends, yes. So remember these answers, huh? These are applicative questions. Scuba divers, okay. Then the at high altitude. So these questions, okay. The oxygen level goes on decreasing. Why? It is due to low atmospheric pressure. So these are some of the important applicative questions. So application questions are asked more on Henry's law. Next, low oxygen level in blood in high altitude region causes. So low oxygen level. So if a person is suffering from very low oxygen level, okay, he has gone to a high altitude region and there the oxygen level is very less in his blood. So it will cause from what it will go through what type of this. Yes. So if a person has gone through a high altitude region, okay, and there he's suffering like the oxygen level has reduced. Okay, now what he'll suffer through? Okay, I have got one answer. Yes, Swati has answered it right. Okay, anoxia. So it is what? Anoxia. A-N-O Anoxia. Okay, what do you mean by anoxia? Spelling Anoxia. Okay, so if a person he has gone to high altitude region and he is suffering from very low oxygen level in his blood, then he's the body he has gone through anoxia. Okay, what it means? Absence of oxygen. The level of oxygen in his blood has reduced drastically. Okay, it has reduced drastically. So it is called as what? Anoxia. Fine. Next is ethylene glycol is used as, okay, where ethylene glycol is used as? Yes, I've got the answers. Hmm. Sanjeevni, Lakshmi, Jyoti has answered it right. Bhavna, yes, good. Okay. Antifreeze. Okay, it is used as antifreeze. Now, what do you mean by antifreeze? It is used for antifreeze. Okay, it is used as antifreeze. So it is able to interfere with the hydrogen bonds in water. So ethylene glycol, it has the ability to interfere with the hydrogen bonds in the water. Okay, so that it makes it difficult the water molecules to bind. So ethylene, so antifreeze. So it is used as a antifreeze. So as ethylene glycol, it is used as an antifreeze. Okay, what it will do? It will help for prevention of this or from formation of your ice crystals. Okay, it helps from formation of your ice crystals so that it can lower the freezing point of your water. So this is the meaning of antifreeze. Next, the membrane which is used in desalination of seawater is. So which is the membrane which is used in desalination of seawater? Which is a membrane? The membrane which is used in desalination of seawater. Okay, I've got some answers. Reverse osmosis, hollow fibers. No, no, not right answer. No. Yes, semi-permeable membrane is used, but what do I say? The membrane is made up of what? The membrane which is used in desalination of seawater is. So what type of membrane is used? Yes, it is right. It is semi-permeable membrane, but the semi-permeable membrane is made up of what? The semi-permeable membrane, it is made up of what? You're right. The semi-permeable membranes are used. But these semi-permeable membranes are used of, yes, Jyoti has answered it right. It is made up of cellulose acetate. Okay, it is made up of cellulose acetate, or it can be one more you can write down potassium ferrocyanide. Potassium ferrocyanide. Potassium ferrocyanide. Okay, so these are the what you can say the semi-permeable membrane. It is made up of cellulose acetate and or or, okay, or it can be made up of potassium ferrocyanide. Okay. Next, human RBCs are isotonic with dash aqueous NaCl solution. The human red blood cells, okay, the human red blood cells, they are isotonic with dash aqueous NaCl solution. Yes. Yes, what is the answer? Human RBCs, it is isotonic with dash aqueous. And how much percent of NaCl solution? In body, NaCl is there. What is NaCl? NaCl is sodium chloride. What is sodium chloride? Your common salt. In body, salt is present. Yes, right. Yes, it is 0.9%. Good. Who has answered it? Sanjeevni. Yes, it is right. It is 0.9%. Okay, it is 0.9%. So human RBCs, they are isotonic with 0.9% of aqueous NaCl solution. Okay. So so why? Because this RBCs, okay, why they are isotonic with this NaCl solution? So that the RBCs, that is the red blood cell, should neither swell nor it should undergo plasmolysis. Okay, neither it should shrink nor it should get swell. Okay, so pure NaCl solution with a concentration less than 0.9% is used here. Okay. So if you replace this, what will happen? Either the red blood cell will swell or it will burst. Okay. So this concentration should be maintained. It is 0.9%. Okay. Next question. People taking a lot of salt develop swelling or puffiness of their tissues. This disease is called as. So some of the people, okay, they take more salt in their food. So when they are having food, they eat more of salt. Yes, what is this condition called as? Yes, M Lakshmi has answered it right. What about others? Is it right? Yes. Is the answer right? People who are taking more salt, okay, they develop swelling or puffiness of their tissue. So what is this as? Yes, most of you have answered it right. Umra, Rohit, Supriya, Sanjini, yes, your answer are right. So it is called as edema. Okay, it is called as what? Edema. Edema. Okay, Edema. Edema. Okay. See, 1 mark question. There should be no chance of spelling mistake. If your spelling is wrong, okay, they'll not give you half. If the answer is right, but the spelling is wrong, they'll not give you half mark also. Directly, it will be wrong. So spelling should be correct. Okay, spelling should be correct. So in 1 mark answers, either the answer will be completely right or it will be completely wrong. Okay, not intermediate. You will not get half mark. So in chemistry, either you get a complete 1 mark or complete 0 marks. Okay. So remember this. So spellings are important in fill in the blanks. Fine. So edema. So people who take more of salt, they develop swelling. Okay. It is caused because of too much fluid. Okay. Too much fluid will be trapped in the body's tissue. So when in our body, so some of the people, there will be more swelling in their legs. Why? Because more water will be what trapped in their legs, right? So so most oftenly what will happen? So most of the fluid will be trapped in their legs and all. So because of this edema, okay. So edema, it can not only legs, it can affect any part of your body. Okay, it can affect any part of your body, but more likely it will affect your feet. Okay, legs and feet. So so edema. Okay, so most of the condition is seen in their legs or else in their feet. Next question. The solutions having same osmotic pressure are called as. Yes, good. Jyoti, Lakshmi, Bhavna. Yes, it is isotonic. We have seen this. Okay, the solutions having, so two solutions when they have same osmotic pressure, they are called as isotonic solution. I hope these fill in the blanks are uh, you have understood. Yes, is it clear? So the remaining MCQs and fill in the blank, is it clear? Shall we move further? Any doubts still here? Whatever has been told till now, any doubts still here? You can ask me. Yes, YouTube students, any doubts still here? Yes, any doubts? Yes. Shall we move further? If there are no doubts. So next is our 2 marks questions. Okay, so we have seen now what is molality, what is molarity, what is mole fraction, and we have seen in the MCQs also, okay, how it is, how it depends on temperature. So these three questions I will bind in one format only. Okay, so in one, this only I'll take it. Okay. Now what is molality? So what is molality? So molality is what? So molality is, yes, what is molality? Okay, first we'll see molality. I've discussed this in, but still molarity, and mole fraction. Okay, we'll see this fast and then we'll continue with our remaining questions. Okay, so molality. Molality is what is denoted by small m. Okay, number of moles of solute dissolved in 1 kg of solvent. Okay, dissolved in 1 kg of solvent. Now, number of moles, it is represented by what? Number of moles. Okay, so small n, I can take it. Okay, so number of moles. So small n, what is number of moles? Number of moles is equals to amount of substance taken upon the molecular mass. Okay, so amount of substance taken upon the molecular mass is yours. So small n upon capital M. Right. Now, so number of moles is also depending on the what? So I'll write it like this. Just a second. So number of moles. So number of moles is what? Amount of substance taken. So that is small m by capital M. That is molecular mass divided by what is 1 kg of solvent. So this is also in term of mass, right? So whenever your it is mass. Okay, so mass is not a time dependent. So it is not temperature dependent. Sorry. So molality will it does not depend on temperature. Now, what is molality? First, what is the question asked? We'll see here. So what is the question? Define molality. So for define molality, what is your answer? The answer is number of moles of solute dissolved in 1 kg of solvent. Okay. So the number of moles of solute, okay, per kg of solvent is called as molality. Fine. So this is 1 mark question, 1 mark for the definition. Another question, how does it depend on temperature? What you have to write? It does not depend on temperature. Okay, it does not depend on temperature. One more thing we'll add here. What is the unit of molality? What is the unit of molality? So for our reference, okay, if there might be a question, what is the unit of molality? Number of moles, it is given by mole, and 1 kg of solvent, it is kg. So it is mole per kg. Okay, it is mole per kg. I hope this is clear. Yes, it is mole per kg. Fine. So we'll go for the next one. Next is what? Next is your molarity. Okay, next is your molarity. So what is molarity now? What is molarity? So molarity is number of moles of solute. Okay, number of moles of solute in dissolved in 1 liter of solution. Okay, dissolved in 1 liter of solution. Volume of solution in liters. Okay, so this is the formula. Molarity is number of moles of solute dissolved in 1000 ml or 1 liter of solution. Fine. Now, number of moles. What is number of moles? Number of moles is again amount of substance divided by the molecular mass. Okay, so it does not depend on number of moles, but so it is molarity. It is given as capital M. Then volume of solution, it is given as in terms of liters. Okay, so it is a volume. So volume is directly proportional to temperature. Okay, you know that volume is directly proportional to temperature. So your molarity, what will happen if you increase the temperature? When you increase the temperature, what will happen to molarity? Molarity will decrease. Okay, so what you have to write? So molarity. So what is the molarity? Okay, as temperature decreases, sorry, as temperature increases, molarity decreases. Same, it is, and vice versa. If the molarity increases, temperature decreases. Okay, it is a vice versa. Understood? So this is the second question. Next is define mole fraction. Next is define mole fraction. Yes, can you tell me what is mole fraction now? Yes, before that, what is the, yes, what is the unit of molarity? Unit of molarity is what? Number of moles of solute is what? It is mole. Okay. Then volume of solution in liters. It is given in ml. Right. It is given in what? Liter. Okay. So it is mole per liter. The answer is mole per liter. Okay. So next is mole fraction. Okay. So the next question was what? So we have seen two questions now. Define molarity. How does it depend on temperature? Next is define molarity. How does it depend on temperature? So these two questions we have seen. Next question. Define mole fraction. How does it depend on temperature? Okay. Yes. Defined mole fraction. How does it depends on temperature? So what is mole fraction? Mole fraction is what? It is given as chi. Okay, it is given as chi. So it is the number of components. Yes, number of moles of a component. Okay, number of moles of component. Number of moles of component divided by total number of moles in a solution. Okay, how it is given as? It is given as, okay, if I take it as chi A, so n of A upon n of A plus B. If it is chi of B, then it is n of B divided by n A plus NB. Okay, that is number of moles. Fine. Yes. So it is a ratio of total number of components to the total number of a solution. Good. Yes. Okay. So this is the now. How do we relate? How does it depends on temperature? Yes. Number of moles is what? We have seen what is number of moles. Number of moles is amount of substance upon molecular mass. So this is a mass dependent. Okay, so this is it does not depend on temperature, mass factor. Then total number of moles again. Okay, again here total number of moles comes. So again here it is also mass. So what is the mole fraction? So mole fraction does not depend on temperature. So mole fraction does not depend on temperature. Is it right? Yes. These three questions are clear. Yes. Is it okay? Yes, YouTube students, is it clear? Yes. Okay. 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 So last question. What is the effect of temperature and pressure on the solubility of gas in a liquid? Give reason. Now, one, so you have to tell what is the effect of temperature and uh, pressure on the solubility of gas. So either increasing or decreasing. So for that, 1 mark, and for the reason, 1 mark. Okay. So what is the effect of temperature and pressure on the solubility of a gas in a liquid, and with the reason you will get another mark. Okay. So if you write only increasing or decreasing, then it will be 1 mark. If you write with reason, you will get another mark. So like this, these 2 marks will be fetched. Okay. So what is the effect of temperature first? Yes. And an increase in the temperature of the, so what will happen as the temperature increases, okay, as temperature increases, there will be decrease in solubility, okay, decrease in solubility of gas. So remember this. Fine. So what is the effect? As the temperature increases, there will be decrease in the solubility of the gas. And what is with respect to pressure? Yes, what is with respect to pressure? So you know that it is directly proportional. Okay. So pressure on solubility of gas, okay, it is directly proportional. According to Henry's law, at a given temperature, the solubility of a gas in a liquid, okay, it is directly proportional to its the pressure on the surface of the liquid, right? So if pressure increases, this on the so pressure it increases, okay. So the effect of pressure, it increases. Fine. So when we increase the pressure on the surface of the water, then the solubility of the gas in water also increases. So this is the reason. Okay. So so if you increase the pressure, then what will happen to the solubility of the gas on the surface of the water? That also increases. So remember this. Okay. Remember. Yes. Good. So temperature, so the effect of temperature with solubility of gas, it is inversely proportional. And with respect to your, so we know now what is Henry's law, right? So pressure is directly proportional to its solubility of gas, right? Then, so if we remove this proportionality sign, then we are introducing the your Henry's constant. Okay. So with respect to at constant temperature, what will happen? The pressure. Okay. So the pressure, if you increase the pressure on the surface of water, the solubility of gas also increases. If you increase the temperature, so the effect of temperature is what? On increasing the this with respect to the temperature. Okay. With increasing temperature, what will happen? The solubility of gas. Okay. It goes on decreasing. Okay, so the volume of dissolved gas goes on decreasing. Fine. So this is the reason. Is it clear till here? Yes. So we have left with some more questions. So this questions and some of the okay, and we need to solve problems also from this part for the 3 marks. Okay, two numericals are asked. Okay, two numericals are asked. Understood? Yes. So is the session clear? Everybody, is the session clear? Any doubts? So if you have any doubts, you can ask me now. Any doubts in today's session? Yes, you can chat in the chat box. If you have any doubts, you can ask me there. Okay. Okay then. So I'll end the session here. Yes, so we'll meet in the next class. Thank you. Have a good day.